side of this is really just basic. We're going to use the quadratic formula. So I have the quadratic formula typed here for you guys at the top of the page. And if anybody's interested, I will be happy to, it takes about a page of paper to do it. But the proof for the quadratic formula, what someone did was they actually took what I have here, just the standard form of a quadratic set equal to 0, and they actually used completing the square with all those variables to do the proof. It's a little bit, it's kind of, I like doing it, but I'm a math teacher. So anyway, it's a lot of work with a lot of letters, but they developed the quadratic formula to actually solve this equation. So it's actually used by completing the square with all the variables instead of numbers in the problem to develop this formula. And you can use this to solve any quadratic equation. We've gone through a bunch of different methods, right? So we did factoring. You can't always find factors, though. Like some of these questions we've had that have had nasty square roots or they've had I in them, you can't factor that. Or we can't always graph because maybe we have imaginary solutions. It doesn't touch the x-axis. We can't always use square roots because maybe we have an x squared term and an x term, so we can't get x by itself and take a square root. And you actually can use completing the square to solve any quadratic equation as well, but you guys probably saw, especially the ones we were working on yesterday, some of the algebra in there can get kind of nasty depending on what the values are in front of your x squared term, especially if it's not 1. Or if your b value is an odd number, completing the square can be kind of a challenge too. However, the quadratic formula can literally be used for any quadratic equation. So we're going to practice this today, and each one of these questions on the front is just a little bit different to show you kind of how the different ways the solutions can look. And the requirement, though, is it does have to be set equal to 0 to apply the formula. You don't have to keep the squared term positive to use the quadratic formula. If your quadratic term is negative, your a value would just be negative, but it does have to be set equal to 0. So if it's not, which it's not in this first lovely question here, we just have to get all the terms on one side. The least amount of work for me to do that in this first question would just be to subtract 4. So we're going to work with 3x squared minus x minus 4 equals 0. Okay, now you don't have to write this out, but I'm going to, especially on the first couple questions we practiced this with. What would you tell me the a value is for that quadratic? 3. All right, what about the b value? -1. If it has a subtraction sign, go ahead and think of it as like a negative number. And what would my c value be? -4. Okay, now all you have to do, and I would put this right in front of you, I'll give you this formula. We're going to plug these values into the quadratic formula. That's going to give us our zeros or our solutions, what x would be to make that an equation that was true. So it's the opposite of b, so it would actually be +1 plus or minus, and then this is a giant square root. B squared would be -1 squared. That term there should always become positive, whether you plug in a negative number or a positive number, because you're going to square it. And then minus 4 is part of the formula. The a value is 3, and then the c value is -4. And then this whole mess is over 2 times the a value. Don't forget that. I feel like people sometimes will just do the top of the quadratic formula and they'll forget the bottom part. The 2 is part of the formula, and then 3 is what I'm going to plug in for a. Now this is just my recommendation because it's a really complicated formula. There's a lot of stuff to plug in. I usually just do one step to kind of simplify this to start out with. I just, not the square root, but I type what's under the square root. So I'm going to take -1 squared. I'm just using my calculator to do this. 4 times 3 times -4. And that, I did not put the square root, I just simplified what was under the square root, so I usually do that. So I have 1 plus or minus square root of 49, and I'm sort of excited about that because I'm like, hey, that's a perfect square. And I usually, you can use your calculator or just do it by hand. 2 times 3 is going to give you 6, yeah. Say that one more time. You can just, I usually do that actually. I usually put in, oh, I did, didn't I? I didn't even put the negative. Either way, a lot of times I won't put the negative only because I know it's going to cancel out and it's just an extra button so I don't have to figure it out. So you could put that in as 1 or -1. Either one would work because it'll give you the same thing. I didn't even realize I did that. I'm sorry. Okay, now, here we go. We have 1. What's the square root of 49? 7. Okay, now here's the situation where I have a perfect square. Now, we can add 1 and 7. We can take 1 minus 7. So I'm going to keep going with this. I wouldn't want to leave my answer like this. 1 plus 7 divided by 6. And then 1 minus 7 divided by 6. Simplify the top first. So the top of that would be 8 and then 6. The top of this we'd have -6 over 6. If you can simplify, we would want to do that. So 8 over 6 does reduce to 4/3. So there's one answer. -6 divided by 6, actually a nice number, is -1. So those are my two solutions. And let me back up. At the very beginning in the directions of the question, it tells you we're going to give exact, and we're also going to try to do approximate solutions. Now, the only time you'd have an approximate solution is if we had something left under the square root, which we don't have here because we had a perfect square. So these would be considered exact solutions because we had the ability to take the square root of the 49. So we don't have an approximate solution here. We just have exact solutions, and that's what I would leave my answer, the 4/3 and the -1. All right. Now, again, if you have a quadratic, it's not set equal to 0. If you want to solve using the quadratic formula, you do have to set it equal to 0. So I'm going to start this guy out and I'm going to add 9. And you don't have to write this out, but I'm going to identify my A, B, and C values. What's my A value for this question? 1. Don't use an X. These should be numbers. Don't ever use a variable. Bless you. Should just be numbers. And it is possible, I don't have any on this page, but it is possible for one of the values to be 0. The B value or the C value could be 0, and you could still use this. The A value can't be 0 because if it was, then you wouldn't have a quadratic equation. All right, now this guy, opposite of B, is going to be -6 plus or minus. B squared would be 6 squared. 4 times your A value, which is just 1 here, times your C value, which is 9. Everybody over 2A, which should be 2 times 1. Now, this one's just a little bit different than the previous question, but what I do is try to simplify what is under the square root. So don't include the square root. I'm just going to do 6 squared minus 4 times 1 times 9. That actually is 36 minus 36, so that's 0. Can I take the square root of 0? You can. 0 is its own square root, right? 0 times 0 is 0, so 0 is actually kind of a perfect square. But if I do -6 plus 0 or -6 minus 0, it's exactly the same thing. So this actually would just be -6 over 2. So my answer is -3. Again, I didn't have anything left under the square root, so we just have an exact answer. I didn't approximate anything. Approximate is going to come if you have a square root and we have to kind of round a little bit if we don't have a perfect square. Does anybody know if I just have one solution to a quadratic equation, like how would that relate to the graph? Like what would that mean if you just have one answer instead of 2? Exactly. So I'm just going to sketch you just a teeny tiny picture. So if my answer is -3, what this means is if we had the graph of the related quadratic, the vertex would just hit -3, 0, and then that's the only piece of the graph that would touch it. So if you just have one solution, that just means to you, one real solution, that means your vertex was the actual answer to the question. Okay. Is anybody having a question so far? All right, now these other two are going to be a little bit more challenging. So I'm going to start out, and any of these we got to set equal to 0. So for this guy, I'm going to add x squared to set that up. So I'm going to have 3x squared plus 4x minus 2 is equal to 0. So now my a value is 3, my b value is 4, and my c value is -2 to plug into my lovely quadratic formula. All right, so opposite of b, -4, plus or minus square root. B squared is 4 squared here, minus 4 part of the formula, times the a value, which is 3, we're going to plug in, times the c value, which is, excuse me, -2. Everybody but divided by 2a, which is 2 times 3. All right, again, I would just recommend, I just type whatever's under the radical, but I don't include the radical. So we're squaring 4 minus 4 times 3 times -2. I'm just trying to keep myself from making a mistake. And so under my square root, on this question, I don't get a perfect square, I get 40. And the bottom of that fraction, 2 times 3 is going to give me 6. So here's what we have to do if we want to write an exact answer. And that is going to be to see if we can break down that 40 under the square root. So if you enjoy the factor tree, please use the factor tree. That's totally fine. If you like to find the biggest perfect square, anybody know the biggest perfect square that would divide into 40? Ethan, what do you think? Just 4. All right, so I could just rewrite. It has to be multiplication. Just rewrite that 4 times 10 real quick. The square root of 4 comes out as 2, and the 10 would stay under the square root. I'm just going to go back over and replace that over here. So the -4 would stay the same, but plus or minus the simplified version of the square root of 40 would be 2 roots of 10, everybody over 6. Now, depends on the question. Can I simplify that expression in any way? I've got -4 plus or minus 2 roots of 10 over 6. Okay, let me show you what you're looking for. Do not touch the radical. Don't touch the radical. Don't change anything like that. What you're looking for here, and it has to be, I'm trying to grab a color I haven't used yet, forgive. It has to be all 3 of these numbers that are around the plus and minus. So this number, and this number. All 3 of them. They have to be divisible by something. If you want to reduce that, don't even look at the radical. If they don't have anything in common, just be done. That's fine. In this particular case, all these numbers are divisible by what? 2. So just reduce it like you would reduce a fraction. This is going to become -2 plus or minus. Now, this is a little weird. The 2 would become a 1. So typically you would not see a 1 written in front of that. If you want to, you can. That's totally fine with me. And then the bottom would be 3. All right, this is as far as we can go. And this is what we would call our exact solution, because this is exactly the answer. In this case, because we didn't have a perfect square, we can get what we call an approximate solution. I'm sorry. Now, we're going to type this in the calculator. So I'm going to do -2 plus the square root of 10, and then I'm going to divide that by 3. The other solution, we're going to do -2 minus the square root of 10, divide that by 3. Okay, now, this is important. And don't write this on your paper. So if I just do like -2 plus square root of 10, and then I divide that by 3, this is not the correct answer. So your calculator will follow the order of operations, and it will actually take that root 10 and divide it by 3 first, because division would come before addition or subtraction. So it's super important. You have to do like -2 plus root 10, hit your equal sign, because you need to simplify the top first. It's a little bit trickier for people to remember to do that with a radical versus maybe a plain number. So do that first and then divide by 3. And you can see that's a totally different answer than what it just displayed when I just typed it in like that at the top. So my actual approximate solution there, it's just going to ask you to do 2 decimal places. This is about 0.39. So that's where we would see it if we were looking at a graph. That's where it would cross the x-axis, just at about 0.39. The other solution, -2 minus root 10, just hit the equal sign or the enter button and then divide it by 3. So make sure your calculator is simplifying the numerator first. This is about -1.72. And so that would be the other place that graph, if we related or if we graph the related quadratic, that's where it would cross the lovely x-axis. So these guys are what we call approximate solutions, because I approximated what I had under the square root by rounding to the nearest hundredth. I would not have done that on either of the two questions we did before this, because we had perfect squares under the square root, and then we had 0 under the square root, which just stays 0. All right, is anybody having a question? Okay, I'm going to try one more with you guys. So set equal to 0 first. And some of these, when you see them on the homework, they'll already be set equal to 0. You won't have to do that extra step, but I just want to practice this with you so I get you in the habit of doing that in case it's not presented to you as it's set equal to 0. A value here is 2, B value is 6, C value is 7. You do not have to write that down or anything. I'm just writing it down so you can see where it comes from. All right, let's do opposite of B. So negative 6 plus or minus square root 6 squared minus 4 times A value is 2 here, C value is 7. Everybody over 2A, which is 2 times 2. So I'm going to get negative 6 plus or minus. Let's see what we got under the square root. So I'm going to square the 6 minus 4 times 2 times 7. Negative 20. And on the bottom, I usually just do this by hand, but you can do it in your calculator too. The bottom of that fraction, 2 times 2 should be 4. If I look at that, what do I immediately know about my answers to this question? If I've got a negative 20 under the square root, we're going to have an I in this. Okay, so if you got a negative under your square root, you're not going to, if we were to graph this, it wouldn't touch the x-axis. We're going to have imaginary solutions. Okay, now, just like the other one, I need to break down the square root of negative 20. So factor tree away if that's your jam. Does anybody know biggest perfect square that would go into 20? 4. All right, I usually just attach the negative to the perfect square so that way I can just remove the I as I do that. Negative 4 is a lovely perfect square in imaginary land. This would come out as 2I, and we'd have a 5 under the square root. So I'm just going to go back over here and replace that into my quadratic formula. So I would end up with negative 6 plus or minus 2I root 5, everybody over 4. Okay, now, same thing as the last question. And this doesn't happen on every problem. I just want to make sure I practice this with you guys. So here, don't touch the radical. I'm just covering it up. I don't even want you to look at it. On this last question, it's more of a temptation because it's an even number, so people will divide it by 2. Can't do that. Has to be this number, and this number, and that doesn't matter. This was a bad marker choice. Forgive. It doesn't matter if it has an I or not. All 3 of those numbers are divisible by what? 2. So you can reduce it. If any one of those doesn't have a greatest common factor with the others, then just leave it alone. But in this case, they all do reduce. So this is just going to become negative 3 plus or minus. We would just have one I, so typically you would just see the letter I and not the number 1. Do not change the radical. That does not reduce. That is not the number 5. It is the square root of 5, which is like 2 point something. So don't reduce whatever's under the radical. You can't do that. Bottom of that would be 2. All right. Now, this obviously is what we would call our exact solution. That is exactly the answer. I didn't round anything. You're not going to approximate an imaginary solution. An approximated solution, we'd take the square root, whatever. And I know I showed you there's an I button on the calculator, but these are really to help you kind of visualize, like, where would this cross the x-axis? This is not going to cross the x-axis. So I'm going to say we're going to have no approximate solution if it's imaginary. So if you have an I, don't type that into the calculator and do like I square root of 5. Don't do that. That's not helpful. It's not going to estimate as a decimal where that would be on the graph because you would not see that cross the x-axis on the graph. So imaginary solutions do not have what we would call an approximate value. They just have an exact value. Is anybody having a question? Okay. Now we're just to do a little application on the back. All right. So a little throwback to our Unit 3 here, where we're going to talk about an object and gravity-based height and time here. So it says a rocket is launched from a 100-foot cliff with an initial velocity of 144 feet per second. Here's the little formula we talked about in our last unit. The -16, remember, that's gravity in feet per second. So since our velocity is feet per second and we're launching this off of a 100-foot cliff, it's in feet, those units are all the same, so that's why the gravity is -16 feet per second. All right, the 100, that would be C in that formula. That's the initial height of the object. We're 100 feet in the air on a cliff. We're going to launch this rocket. So that's your initial height. And your velocity goes in for V. That's the speed the object is launched at. So the formula here, we'd have -16t squared plus 144t and then plus 100. Right, and then I know those are all divisible by 4. Actually, I'm not gonna take a greatest common factor out here. Okay, we'll just leave it alone for the moment because we're not gonna use that equation at the very beginning of this. Okay, so I'm just gonna sketch a tiny picture. This is not accurate in any way, shape, or form. I'm not going to start at the origin because it says it's launched off of a 100-foot cliff. So just somewhere on wherever you sketch your y-axis, I'm just going to say, okay, that's 100. And we're going to go up in the air, and then eventually gravity will bring the rocket back down to the ground. Okay, now it says what time does the rocket reach the maximum height, and what is the maximum height? This is just a little throwback to Unit 3, but this is just the vertex. Okay, now we could theoretically complete the square to find the vertex. Let's not do that because it's a lot of extra work if there's a number in front of the squared term. I'm just going to do -b/2a, and then I'm going to plug in -b/2a. The reason I'm doing that, if you guys look at the formula, the t is where you're used to seeing x, so the time is like your x coordinate, and where you guys are used to seeing y, that's the h. So the time is like the x-coordinate of the vertex, the height is like the y-coordinate of the vertex. So if I want to find the time it takes to reach the maximum height, I just need to find the vertex of that parabola's x-coordinate, which would really be the time. So opposite of b there, be -144. And then you got to remember this too. This is kind of similar to the question on the front. 2a would be 2 times -16. You have to figure out what the product is on the bottom of that fraction before you do the division. So if you just type it directly in your calculator, it's not going to do it correctly. Either put parentheses around the bottom of that or figure out what the bottom of that is. It should just be -32. The negatives are going to cancel out there. So we're going to have our time, this is in seconds. So I got 4.5. That's how many seconds it would be. To actually find the height, and you don't have to write this out, but I'm going to plug in 4.5 everywhere I see a t. Don't forget to square it in that first term. I feel like that's the most common mistake people will accidentally make on their lovely calculator. So it's -16 times 4.5 squared plus 144 times 4.5 plus 100. Oh shoot. 100. All right. 424, and the height is in feet. So that'll be the maximum height. And I should not have drawn that so close to that. But there's my vertex. It would be 4.5 and 424. Now, the reason I wrote that on the graph, because I want you to think about this before we do the next question. So it says, at what time or times does the rocket reach a height of 343? So, if I look at my lovely picture I just sketched, the maximum height I hit is 424. So, am I going to hit 343? Right. So, okay, now, think about this too. So, you're starting at 100. You're going to go up, and then eventually you're going to come back down. So, you're actually going to hit 343 somewhere on the way up, and you're also going to hit it somewhere on the way back down. Here's all you have to do. We want to know when the height is 343. So I'm just going to plug 343 in for h in the formula. So it's going to be 343 equals -16t squared plus 144t, and then plus, excuse me, 100. to actually solve this, the easiest thing I can tell you to do, let's just set it equal to 0. So to do that, I got to subtract the 343. And then we end up with a quadratic set equal to 0. And I know these numbers are a lot larger than what we were working with on the front, but we can just use the quadratic formula on this. The key is you got to make sure you plug in the height that they wanted, which was the 343, and then you would have to subtract that, and it's going to get subtracted from that initial height, which is the 100. Okay, now, this is going to be really nice for us. So it just says we want to round to the nearest 100th of a second. So that tells me I don't have to break down a radical or anything under the quadratic formula. We're just going to type it into the calculator. So opposite of b would be 144 but negative, plus or minus square root. We'd have 144 squared 4 times negative 16 times negative 243. Let me see if I squeeze that on there. All over 2 times negative 16. Okay, so what I like to do, just take whatever's under the square root. So 144 squared minus 4 times negative 16, negative 243. I didn't take a square root, I just tried to simplify that. So plus or minus, this is 5184. The bottom of that fraction is negative 32. To get my actual answers here, I'm just going to type this in the calculator. So I'm going to do negative 144 plus square root 5184. I'll just go ahead and hit equals. Okay, to me that implies that 5184 must be a perfect square because I got a nice number there. And then I'm going to divide that by negative 32. So if I did the plus, I got 2.25. That would be the time. So 2.25 seconds. And we know we're going to hit that on the way back down too. So I'm going to do 144 minus square root that 5184. It must be a perfect square. And then I'm going to divide that by negative 32. So my other time, 6.75 seconds. So those are actually pretty decent decimals. And that's going to be created by that 5184 being a perfect square. If that's not a perfect square, then those probably would be more garbagey looking decimals. Is anybody having a question? Okay, now I feel like these questions always ask you, this last example here, what time is the rocket going to be on the ground? What's your height if you're on the ground? 0. All right, all you got to do here, we're actually just going to solve the equation at the top with a 0 plugged in because I want to know when the height is 0. Okay, now, totally up to you. Each of these values are divisible, I'm pretty sure by 4, maybe something bigger, I don't know. At least 4. You can divide everything by 4 if you want to. You would be working with smaller numbers, but we would get the same answer as if I were to use these numbers. The other thing I want to show you just real quick, if I look back up at the picture, how many answers am I going to have to that question? 1. Because if you guys look at the way this is drawn, the other answer should be negative, which would mean a negative time based on where that rocket was launched there. So if I had this parabola, I did not do a good job drawing this, but the other answer should be negative. So we should just have one solution that'll be positive here. I'm just going to go ahead and use the numbers in the problem. Like I said, if you want to reduce those, you totally can, but you don't have to because we'll get the same answer. All right, so I'm going to do opposite of b, negative 144, plus or minus square root 144 squared minus 4, part of the formula. A value 16, C value is 100. Everybody's over 2A. And if you don't want to write that out, if you want to just do that on your calculator, as long as you understand where it's coming from, I am fine with that. But I'm going to take 144 squared 4 times negative 16 times 100. So under my square root, I got a huge number. 27,136. The bottom of that fraction would be negative 32. Okay, now I'm going to show you this, but then I want to have you think about it. If I do negative 144 plus the square root of that 27,136, and then I'm going to divide that by negative 32, you guys are going to see I get negative point, like let's say 65. You cannot have a negative time, so we would not select that as our answer. If I was being smart about this, I would know that my answer has to come from me doing negative 144 minus that square root. Does anybody know why I would know that? Like, how do I know I'm going to get a positive answer if I'm going to subtract that on the top? You got a negative on the bottom. So you got negative 144 minus, that's got to be a negative number, divided by negative 32. The two negatives have to cancel out to give you a positive answer. So that's how I know for sure that I should get a positive answer doing that, because I'd have a negative divided by a negative. So if you want to save yourself a second, if you know you're going to only have one answer, then think about like, okay, what's going to give me a positive value, because one of them is going to give you a negative. And then this would just be a time in seconds, so it's going to be about 9.65 seconds. Is anybody having a question? Okay. Now, I've got an area problem, and I know we've done a couple of these, but they had nice answers, and this one does not. So I want to show you real quick how to do this. So it says length of a rectangular poster is 6 more inches than the width. So I'm just going to sketch a super tiny picture over here. So let's say the width is W maybe, and the length is 6 inches more than that, so W plus 6. And then it says the area is supposed to be 400 square inches. Alright, so length times width here, I could do W times W plus 6, or use your favorite variable, is equal to 400. And so we'd have W squared plus 6W equals 400. Okay, now it doesn't tell me how to solve this, but I will tell you up front, if you set the 400 to the other side, this is not factorable. You're not going to think of factors of negative 400 that add up to 6. These answers are not nice. The way I wrote this, this would actually be not too bad at all if you wanted to do completing the square. And I would say here it might actually not be too bad to do, because the B value is a 6, which is an even number. So if I wanted to complete the square, just to review a little bit what we've been doing the last couple of days, this would be easy. My A value is 1, my B value is even. We could just do 6 divided by 2 squared, 3 squared, and we could add 9 to both sides. Alright, your factored form of this would be W plus 3 squared, and to actually add that 409, it's not a nice square root when you do this. So I'm going to take the square root, and just to save some space because I'm so at the bottom of the page here, I'm going to subtract 3, but it would be plus or minus that square root of 409. Okay, now I'm not going to worry about reducing that because it says we're going to round to the nearest hundredth. Okay, now I want to show you. If you were like, hey, I like the quadratic formula better, what we were working on today, you could do that too. You could just set this equal to 0, so I would have to subtract the 400 before I picked my A, B, and C values. But then I could also, if I liked the quadratic formula better, just do that. So it'd be negative 6 plus or minus, let's see, 6 squared, 4 times 1 times negative 400. Everybody over 2 times 1. And let me see what that is under the square root. And I'm just going to show you guys, this is going to give me the same answer. So it's whichever method I want to use. You're going to get under this square root 1636. This will be over 2. Now, I know these look a little bit different, right? But if I do negative 3 plus the square root of 409, I get 17.22 whatever. If I do negative 6 plus the square root of that 1636 on my quadratic formula, and then I'm going to divide that by 2, you see those are identical. Those decimals are exactly the same. It's 17.22. And that's a positive answer. So I'll go ahead and write 17.22. Now, for both of these, if I do negative 3 minus root 409, or if I do negative 6 minus square root of 1636, and then I divide that by 2, Again, you can see I got identical answers, but they were both negative 23.22. You can't have a negative length or width, which would be what's going on for this rectangle here. So the dimension I'd want to pick, but you could see I got the same answer, just two different methods for doing it. So if you like the completing the square better, cool. If you like the quadratic formula better, cool. It's your choice. You can pick whichever one you want since they didn't tell us what to do. Yeah, you can do either one. You can do either one. Either one. We're going to actually spend a little bit of time tomorrow talking about like what might be the best strategy for solving the quadratic. Like I said, this one probably either one of those would work well. Now, if I had W plus 7, maybe I don't want to mess around with completing the square because then I'm working with fractions and stuff. But maybe I don't mind that, so it's up to you. But this would be nice because of the even value to do completing the square, or you can use quadratic formula on any of these questions. Now, technically, I was supposed to write the dimensions. So for the question, the 1722 would be the width, and then I would have to add 6 to that. So 23.22, this would be your width, and this would be your length if they ask you for both. Is anybody having a question?